Okay, let me start by apologizing. I think the lesson 2 was while I was out, so I didn't ever get a recording done for this. So it's a little late, but hopefully late is better than never. So follow along. I'm actually doing this during my prep period, so there's no interaction with kids on this one. I'm just going to go through the handout for the student handout for our lesson 2 notes and make sure you guys at least have access to this. So in lesson 2, we're actually talking about tables and proportionality. So our warm-up exercise on this one, the coffee shop displays their prices on a chalkboard menu. The prices are proportional, but some of the information got erased. So what is the constant proportionality is our first question. At any point, remember in our tables, the first is normally x, the second is normally y. Our constant of proportionality hasn't changed. It's still k equals y over x. All that means is I can take any of these points and I should be able to figure out what it is for 1. So in this case, we've got the 550 over 2. You could also use the $11 over 4 to find it. So our k is going to equal the y, which was $5.50 over 2. For our constant proportionality, we're trying to get it as simplified as we can, meaning I'm going to divide both these by 2 to give me $2.25 over 1, which is simplified to $2.25. So there is our constant of proportionality, 225. How can you use the value of k to find the missing prices on the menu? So how can we do that? And it basically comes down to whatever my k, whatever my x is. I'm going back to my formula of y equals, in this case, $2.25 times my x value. So you're just putting that x value in, multiplying it by 225. So at 1, it is $2.25. And at 3, it's going to be $7.75. You can also use the basic relationships of a table. These are going up by 1. So if these are going up by 1, these are going to go up by 225. So all I need to do is add 225 to this, and at a 550, it gives me the 775. How does the total cost change as the cup of coffee increase by 1? The total cost is going to increase by 225, or your constant proportionality.
Hey, sir.
Yes?
Look at you. You showed room again.
Yeah? Okay, moving on to our next problem. So the rate of change describes how one quantity changes, it's really tricky there, in relation to the other quantity. In a proportional relationship, the rate of change is equal to the constant of proportionality, or k. In other words, you're going to find it the exact same way. Your rate of change is also going to be found by taking your y value over your x value. So literally, it's the exact same thing, guys. Normally, just rate of change we're talking about on tables and graphs. So how is it going up? So a representation of a proportional relationship is given. Use the information to create a table to represent the relationship, then find the rate of change. Okay? So, interestingly enough, if they've given you the equation, they've also given you the rate of change. The way to use the equation, though, to fill out the table is you just take your x value, you're going to substitute it in. So this one is going to be, y is going to be 9 5/10 times 0. Anything times 0 is always going to be 0. Then for our next one, 9 5/10 times 1. So that one is going to be 9 5/10. Our next one, 9 5/10 times 2. So that one is going to be 19. And then 9 5/10 times 3, which is going to give you 28.5. And then your rate of change is 9.5. Guys, it's really not complex. If they've given you the equation, they've given you the rate of change because it's your k value. The other way to find it, though, if you really needed to, you can come back to your table, divide your y by your x, and you will also get the rate of change. So you're saying there's multiple ways to get the exact same thing. A representation of a proportional relationship is given. Use the information to create a table to represent the relationship, then find the rate of change. So kind of the same deal as we just did. We've got to create the table and then find the rate of change. The x values increased by 2, the y values increased by 60. So what that means is at 2, my y value is 60, so I can now find that. Remember that my constant is the y over the x. So now that they've told me that, k is 60, the y value divided by 2, which equals 30. So that means that 1 is going to be 30. I can now again use my relationship. So that's going to be 90 and 120. We can now find our, we could have written the equation if we wanted to. Y equals 30x. They didn't ask for that, so you didn't have to put that. But we do know that our rate of change is 30. Camping Craze hires a graphic designer to create a new logo and marketing materials. The designer charges $45 per hour. Complete the table and then answer the questions, A through C. The first thing that wanted us to do was to complete the table. You can start your table in 2 ways because we're talking about proportions. I would start it at 0. If you wanted to start at 1, I wouldn't have counted it wrong. For your first hour, I know that that's going to be $45, meaning your second hour is going to be 90, my third hour is going to be 135, and my fourth hour is going to put me at 180. So find the rate of change. That's going to be our first one. It's going to be that y value, $45 per hour, which is going to be $45. What does the rate of change represent in the context of the situation? It is the amount being paid for each hour of work. Write an equation to show the relationship between x, the number of hours, and y, the total charge of the graphic designer. So here's where you're finally getting it said. It had not said that earlier, but normally when we talk about it, dollars per hour should be really common sense for you. So to write my equation, I now know that my rate of change, or my k value, is 45, meaning my y is going to equal $45 times my number of hours x. Ronnie earns $27.50 for each driveway he shovels. Create a table to show the sum of the amount Ronnie will earn shoveling 4 driveways. So they didn't fill this table out for us, but normally when we're doing a table, it's going to be x on top on y and y on the bottom. And they kind of gave it to us here in our initial one, $27 for each driveway. So the top one is going to be our dollars earned. Our second is going to be the number of, actually I take that back. This is going to be the number of driveways. And this is going to be the dollars earned. You'll notice I took a step back because I said this is $27.50 per driveway, and I think if you write it out as a fraction first, that will make sense because we know this is the y, this is the x. So when I did it, I just kind of said, oh, that was first, that's my x, but it actually isn't because the way they have it set up, this is my y value. So make sure you put them in the correct spot. So for one driveway, he's getting $27.50. For 2 driveways, he's going to double that, so that's $45. For 3 driveways, he's going to get $72.50. And for 4 driveways, he would get $90. So nothing else we needed to do on that one. So that should set you up for that. Gasoline is priced at $3.39 per gallon. Write an equation to represent the total cost, Y, of purchasing X number of gallons. So that kind of gives it to you. So I know that it's going to be $3.39 per gallon. So this is my Y over my X according to the thing. So that we know that's going to simplify to $3.39. Gives me my constant of proportionality. Now I can put it in the equation. Y equals $3.39 times X. This done answer is to represent Y equals 5X in a table. Which students correctly completed the task? Explain your reasoning. So what is our biggest thing? We have to explain it. So we want Y equals 5X. Remember that Y, the K value is your Y over your X. So does 5 over 0 equal 5? I don't think so. That would be a 0. Actually, can't do it. Can't have 0 in your denominator. 10 over 1 would equal 10. On this one, he started at 0, 0. So 5 over 1 equals 5. 10 over 2 equals 2. So Ronald would have been correct. The reasoning, when you put the data from the table, in X and Y over X, Sasha started at 5 over 0 instead of 5 over 1. Ronald did it correctly. Technically, you could have also said, because we know that it's proportional, I have to have the point 0, 0. Sasha did not do that. Only Ronald did. So either of those explanations would have been just fine. Michelle reads a book from the school readathon. The table shows the proportional relationship between X, the number of minutes, and Y, the total number of pages read. So determine the rate of change and explain its meaning. We have two parts in the context of the situation. And then we're going to write an equation to represent the total number of pages as it relates to the number of minutes read. Remember, whenever we're looking at a table like this, X is my first value, Y is my second value. So to find my rate of change, I need to put the Y 15 over the X 30, which is going to simplify to 1/2. And now putting that in context of the situation, what does that mean? This means she can read 1 page every 2 minutes. Or it takes her 2 minutes per page to read it. Write an equation. So now we're going to say Y equals 1/2 X. If you ever want to check it, you can just put that in. Half of 30 is 15, half of 60 is 30, half of 90 is 45, so that does work. And that was all they asked for that part. Our next one, Crystal creates a tower of playing cards. The number of cards of each level is shown below. Complete the table below to represent the rate of change. So if I look at my picture, you actually have to count. I can see I have 1, 2, 3 cards. So at one level there were 3 cards. As I go up, it's now 1, 2, 3, 4, 5, 6. At 3, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 cards. So now that we've formed the relationship, you should be able to keep going. So you know, at 4 it's going to be 12, at 5 it's going to be 15. So that represents our rate of change, but we haven't actually calculated it yet. So remember, on a table, it's X and then Y. My K value or constant or rate of change is always going to be y over x. In this case, it's going to be 3 over 1 or 3, which now allows us to write an equation that represents the number of cards, y, as it relates to the level of the tower, x. So now our equation is Vy equals 3x. In other words, for every level of a tower, I need 3 cards. And our last one, I think. Sue traveled by car at a constant rate. After 4 hours, she had traveled 272 miles. Circle any of the following that represent the relationship between the distance traveled and the hours of driving. So we need to circle any of them. So on this first one, in order to find our rate of change, we actually need to start at the 272 to 4 to figure out what the rate of change is. So if I start at 272 miles over 4 hours, I know I can divide both those by 2 to make it easy. It gives me 136 over 2, which I can still divide by 2 again to give me 68 over 1. So she's traveling pretty quick, 68 miles an hour. But then I can now use that information to see if this actually equates. So I'm going to take that, I want to make it into 5 hours. So I'm going to have to multiply them both times 5. So I take 68 times 5, I get 40, 340. So I can see that that matches this one. And from there I can just add in the 68, and I can see that that is going plus 68, plus 68. So this one does show it. So A is one that shows. D equals 272t, where D is the distance traveled in miles and T is the time in hours. That would not be correct because that was at the 4 hours that is 272. When we find our rate of change, we find it was actually 68. So it should have, if that had said 68t, it would have been correct, but 272t is not correct. And Sue is traveling 68 miles per hour. Again, when we find our rate of change, that is exactly what it came out to be. So C is also correct. So 2 of the 3 were correct. And here was your homework. If you had any troubles on the homework, guys, please make sure you're taking opportunity of the chance to come in and see me at seminar. Good luck. Let me know if you have any questions.